Hello everyone, welcome to another video on compiler design. This is our fourth video on the subject and we're going to be covering DFA minimization. We likely won't be using DFA minimization in our later lessons, but it is good to know when you're working with DFAs. DFA minimization is the process of taking a DFA D, which accepts a language L, and finding the smallest possible DFA, let's call it E, which also accepts the same language L. To do this, we're going to need to find states that are equivalent in transitions and merge them. Now, let me show you how to do that. Given, let's say, this DFA with states A, B, C, D, E, F, where B, C, and F are the final states, we also know it can take inputs 0 and 1. We need to make a table that is 5 rows by 5 columns, and it's halved, basically halved. To make this table, what we really do is we actually make a table with 6 rows and 6 columns, but then we chop off half of it and the diagonal, because we don't need to, we're going to be comparing states effectively, and we don't need to compare states with themselves, so we don't need AA or BB or so on and so forth. To start with, what we need to do is go through this table and tick any pair of states where one state is a non-final state and one state is a final state. For instance, BA, well, B is a final state and A is a non-final state, so we need to tick this. CA, again, C is a final state, A is a non-final state, so we tick this. DA, they're both non-final, so we don't need to tick this. EA, they're both non-final once again, so we don't need to tick anything. FA, F is final, A is non-final, so we do tick this. Now next, let's take a look at CB. They're both finals, so we don't need to tick them because they're both the same. DB, we do tick this. EB, we do. FB, we don't because they're both final again. DC, we do tick this. EC, we do. FC, we don't. ED, we don't. FD, we do, because again, F is a final state, D is a non-final state. FE, we do. Okay. Next, what we do is we look at all of the non-ticked pairs and we need to compare them as such. So for instance, for CB, if C is given an input of 0, then it ends up at E. If B is given an input of 0, it ends up as D. We need to look and see if DE is checked. Well, is DE checked? No, it doesn't have a tick. So we don't tick CB for now, but we also need to take a look and see if B is given an input of 1, it goes to E. If C is given an input of 1, transitions to D. Once again, D is not checked, so we don't need to check CB. What about DA? Well, if D is given an input of 0, it goes to F. If A is given an input of 0, it goes to B. BF is not checked, so we don't check DA. And what about 1? Well, if D is given an input of 1, it goes to F. If A is given an input of 1, it goes to C. CF is not checked, so again, we don't check DA. What about EA? If E is given an input of 0, it goes to F. A goes to B. If E is given an input of 1, it goes to F, whereas A goes to C. Again, in both of these cases, BF and CF are not checked, so we don't need to check EA. What about FB? Well, if B is given an input of 0, it goes to D. If F is given an input of 0, it goes to F. DF, as we can see, right here, it is checked. So we do check BF. And now what about FC or CF? It doesn't really matter which way around it is. If C is given an input of 0, we transition to E. If F is given an input of 0, we transition to F. EF, as we can see, is checked, so we do check CF. Okay, and what about ED? Well, both 0 and 1 on E and D goes to F, so it's FF for E and D in both cases, and FF can't be checked. If you get a state and itself, then it's automatically unchecked. So ED does not need to be checked. Now let's go over this one more time. We need to keep going over until there's no more checks to be made. So CB, well, C given an input of 0 goes to E, B given an input of 0 goes to D. Is ED checked? No, it's not. B given an input of 1 goes to E, C given an input of 1 goes to D. Is ED checked? Once again, no, it isn't. So next, let's take a look at DA. So DA, if D is given an input of 0, it goes to F. If A is given an input of 0, it goes to B. BF is checked. So we need to check DA. What about EA? If E is given input of 0, it goes to F. If A is given input of 0, it goes to B. BF, once again, is checked, so we need to check EA. What about ED? Once again, if D is given an input of 0, it goes to F. If E is given an input of 0, it goes to F. FF is not checked, because it can't be, since a state in itself can't be checked. And 1 gives the exact same result of FF again. So ED will not be checked. Let's check CB one more time to be sure. C given an input of 1 goes to D. B given an input of 1 goes to E. ED is not checked. C given an input of 0 goes to E. B given an input of 0 goes to D. ED is not checked. So CB and EED are not going to be checked. So let's circle these here. What this tells us is that, as we've seen here, these states are equivalent in transition. So they need to be merged. So it's BC is going to be made into one state, and DE, these are going to be made into one state as well. So we're going to have a state called BC and a state called DE. Let's also circle A and F, just to represent that these are the 4 states that we're going to have. Now, let's draw out our minimized DFA. Oops, let me change that to the circle. Okay, so this is going to be A. This is going to be BC. This is going to be DE. And this is going to be F. So how exactly are these going to look? Well, let's label them too. So A, B, comma, C, D, comma, E, and F. Now what do we need to make sure? Well, we need to make sure that BC and F are final states, because F is a final state and B and C are both final states. Let me just center this a little bit more. Okay, and let's represent our transition. So this is the start. This is A to BC, BC to DE, and DE to F. Okay. Now we know F is the exact same. It's just going to be 0 and 1, both lead to F. A, well, if A got a 0, what did it lead to? It led to B, didn't it? So 0 is going to lead to BC. And if A got a 1, it led to C. So 1 is going to lead to BC, once again. If B got a 0, it led to D. If B got a 1, it led to E. If C got a 1, it led to D. C got 0, it led to E. So it led to either D or E for both of them, whether they got a 0 or a 1. So a 0 or a 1 from BC is going to lead to DE. And once again, for both, even simpler this time, for both D and E, a 0 or a 1 leads to F. So let's draw that out. Okay, and this is our minimized DFA. So you can check for yourself that this DFA will take the exact same language as this one does. For instance, to get to a finishing state at F, we can do 0, 0, 0 or 1, and then we get to F. So 0, 0, 0 or 1 leads us to F here as well. What about 1, 0, 0 or 1? Well, 1, 0, 0 or 1 leads us to F once again. What about some non-finishing states? So if we get no input, it should be a non-finishing, we should end up in a non-finishing state. Well, again, we end up in a non-finishing state. If we get 0, 0, we should end up in a non-finishing state. Well, 0 followed by 0 puts us in DE, which is a non-finishing state. If we get 1, 0, once again, it's a non-finishing state. So 1, 0 leads to DE, that's a non-finishing state. So you can see it accepts the same language. The same combinations of zeros and ones lead to the same either non-final or final states for both of these DFAs. So that's the basics of DFA minimization covered with a very basic example. We will probably do another more complicated example in the next video or maybe another video. But for now, thank you very much for watching. I hope you enjoyed. See you next time.